for this equation here, we see that, this identity I should say, we see that the left side is more complicated. So we're going to go ahead and multiply out the left side. And if you remember the factoring pattern of a plus b times a minus b, that's the difference of squares factoring pattern. So anytime we see the same term in the first and the same term in the second, and then in the first set of parentheses we have a minus sign, the other set we have a plus sign, then we know we have a squared plus, or a squared minus b squared, which means that secant times secant is secant squared. And then if we know that the outer plus the inner are going to add up to 0, and then we have minus 1 times 1, so minus 1. Again, we're not going to touch the right side, so we're going to put a box around that. Secant squared minus 1. So if we remember, we're probably almost done here. So if we remember, sine squared plus cosine squared equals 1. If we divide every single one of these terms by cosine squared, then we get sine squared over cosine squared, everything over cosine squared. Sine squared over cosine squared, that's tangent squared of theta. And then plus 1 equals 1 over cosine squared, that's secant squared. So notice if we subtract 1 from both sides, that we have this Pythagorean identity that says tangent squared of theta equals secant squared of theta minus 1. And that's exactly what we have here, secant squared of theta minus 1. That's automatically equal to tangent squared of theta. So we're done.